This is the third part to the tutorial for the 3x3x3 Venus. In the last two parts, we finished solving all of these crosses and all the circles. Now in this remaining part, all you want to do is to swap these corner pieces around and rotate them until everything else is solved. And depending on the algorithm you use to swap the corners of the last layer, usually, it can differ on whether or not you can actually use it or not. For example, the one I use involves the top, right, and left sides, and I just want to make sure that all three of those sides I'm using are like this red and not like this white. So they can move freely from the circle, unlike this one, which moves with it. If they all move freely from the circle, then no matter which algorithm you do, these inner corner pieces should stay where they are. But if you involve a white side like this, then these corner pieces could get messed up. So the algorithm I use, I'm going to first look around and see which ones are partially solved or completely solved. If they're already completely solved, then you have to try to ignore those as much as you can. But if they're only partially solved, like this one, where only one of the sides are solved, then I can start here as a reference. So the algorithm I do is going to turn this one up over here. This one will come over here, and this corner piece will come over here. So looking at the way this is placed, I can start over here, because if I start here, then this piece will come over here, get completely solved. This piece will also come over here and get completely solved as well. So I'm going to start with the piece I'm not moving towards my right, like this, and other pieces all around here. So from here, I'm going to do, when the piece I'm not moving is on the right, I'm going to start with L inverted, U, R, U inverted, L, U, R inverted, and 2U. So now that solves these two, and look for any other pieces just like that. So here I can do this one. I can put this one over here. But the only problem right now is this piece is also partially solved, so I really don't want to mess this up right now. But if I do the algorithm from here, then this piece will eventually come over here, not where I want it to. So what I want to do is start over here, so that I don't move this around, and do the same exact algorithm. Like that. Now I can move this piece over here. And this piece actually has to come down over here, but since they're across the yellow side, which is fixed, I'm not really going to worry about that right now. So now I'm going to move this piece, the solved piece, over to the right, do the same thing. Now there's 1, 2, 3, 4 pieces left unsolved. Now none of these seem to be partially solved at all, so I just want to put them as best as possible into their correct places. So I'll do the same algorithm as before. That's going to move this piece here. So like I said, this one is not partially solved or completely solved, but it is in the right spot. Now I see that I can move this one over this way to solve this corner piece. So what I'm going to do is to bring these two unsolved pieces and this unsolved piece both over to the green side. And from here I can do the same algorithm, except this time I'm going to do the exact opposite. So unlike before where this one moved over here, I'm going to have it where the right side moves over here to solve this piece. So again, since this is I'm going to start with the right side turning, I want to have the solved piece on the left. So from here, it's pretty much an inverse of the previous algorithm. It's R, U inverted, L inverted, U, R inverted, U inverted, L. And now just put this exactly as it was before. And now I'm done with everything else, and now I just have to rotate these two corner pieces. So again, I want to have them both on the same side, but I don't want them on the same yellow or white side, because those two are fixed. So I'm going to put them both onto the green again, and see which direction they have to rotate. This one goes counterclockwise, this one goes clockwise. And the algorithm I use for this, for rotating the corners, involves top, right, and bottom. So I just want to make sure that none of them are the white and yellow. And if that's unavoidable, you have to find a different algorithm to do it. So first, I'm going to have the piece that I'm rotating first to be on the back right. So I'm going to put this one over here. This one goes counterclockwise, so I have to start with the bottom. It's going to be D, R, D inverted, R inverted. One more time, so twice. And then rotate this next piece I have to solve, and turn this one clockwise. So instead of starting with D, I'm going to start with R. R, D, R inverted, D inverted, twice. And put everything back exactly as it was. And that's how you solve the crazy 3x3x3 Venus. Thank you for watching.